The sun is the lifeblood of our solar system. It provides the energy that supports all life on Earth, drives our weather patterns, and keeps our planet in orbit. Without the sun's gravity, the planets would drift away into the darkness of space. And Earth would become a frozen wasteland, losing its ability to sustain life. The sun's gravitational pull also keeps the solar system intact, maintaining the balance that allows everything to orbit in harmony. But what if we replace the sun with something far more extreme? Imagine we replace the sun with Proxima Centauri, the closest star to our solar system. Proxima Centauri is a red dwarf star, and it's very different from the sun in a few important ways. First, it's much smaller, about 1/8 the size of our sun. It's also much cooler and dimmer because it doesn't produce nearly as much energy. If Proxima Centauri suddenly appeared where the sun is, Earth would change in ways we can barely imagine. Since Proxima Centauri is smaller and cooler, it doesn't shine as brightly. Instead of the warm, yellow sunlight we're used to, the light would be faint and reddish. It would feel like being under a dim, red sunset all day long. The big problem, though, is that Proxima Centauri doesn't give off nearly enough heat to keep Earth warm. With so much less energy reaching us, our planet would start to freeze. The average temperature on Earth would drop quickly, and it wouldn't take long before everything was covered in ice. Without enough warmth, the oceans would freeze solid, plants would die, and life on Earth wouldn't be able to survive for very long. Even though Proxima Centauri is dimmer, we would still have day and night because Earth would keep spinning as usual. However, the days would look much darker, with that reddish glow replacing the bright sunlight we know. Nights, on the other hand, would be far colder than they are now, with temperatures dropping even further in the darkness. Proxima Centauri's weak energy wouldn't be enough to create the seasons we experience today. Without the sun's heat, Earth's tilt and orbit wouldn't cause the same warm summers and cold winters. Instead, the planet would be locked in a kind of permanent deep freeze, with hardly any difference between summer and winter. One thing that wouldn't change as much is gravity. Proxima Centauri is smaller than the sun, but it still has enough mass to keep the planets, including Earth, in orbit. However, the slightly weaker gravity might cause planets to shift a bit in their orbits, but they wouldn't fly off into space. Earth would keep orbiting Proxima Centauri, though everything else about our world would be completely different. Even though Earth would still orbit Proxima Centauri, it wouldn't be enough to save us. The cold temperatures and lack of sunlight would make Earth uninhabitable. Any remaining life would struggle to survive. The few creatures that might adapt to extreme cold wouldn't last long, and humans, plants, and most animals would be gone. In short, replacing the sun with Proxima Centauri would turn our once vibrant, warm planet into a frozen, lifeless world, trapped under the faint glow of a distant, dim red star. Now, let's imagine something truly enormous, replacing the sun with Stephenson 218, the largest known star in the universe. Stephenson is a supergiant, and its size is almost beyond comprehension. To give you an idea of how big it is, Stephenson is over 2,000 times larger than the sun. If this star took the sun's place, its surface would stretch far beyond the orbit of Earth, completely engulfing it, along with Mercury, Venus, and Mars. This star is a red supergiant, meaning it's not only gigantic, but also much cooler than the sun in terms of surface temperature. However, don't let its cooler surface fool you. Its sheer size means it gives off an incredible amount of energy and heat. If Stephenson 218 replaced the Sun, the first and most immediate consequence would be total destruction. Earth wouldn't stand a chance. Our planet would be vaporized instantly, as it would be engulfed by the outer layers of this massive star. We wouldn't have a slow freeze like with Proxima Centauri. Instead, the intense heat and radiation from Stephenson would completely obliterate everything. Stephenson's immense gravity would drastically affect the entire solar system. The outer planets, like Jupiter and Saturn, which are much farther from the Sun, might survive, but they wouldn't be safe either. The gravitational pull of this supergiant would likely disrupt their orbits, pulling them closer and potentially destroying them as well. The delicate balance of the solar system that the Sun's gravity maintains would be thrown into chaos. Now, let's take things to an extreme by replacing the Sun with a quasar. A quasar is one of the most powerful objects in the universe. It's essentially a supermassive black hole at the center of a galaxy, surrounded by a disk of gas and dust. As material falls into the black hole, it gets heated to incredibly high temperatures and releases huge amounts of energy, brighter than entire galaxies. If a quasar took the Sun's place, the results would be catastrophic. Quasars are unbelievably bright, so bright that their light can be seen across billions of light years. The energy output from a quasar is so intense that the Earth would be bombarded with deadly radiation. This radiation would strip away our atmosphere in seconds, and everything on the surface would be scorched and vaporized almost immediately. The sheer power of a quasar would turn the solar system into a furnace. Planets would be fried, oceans boiled away, and life would have no chance of survival. The immense gravitational pull of the quasar's black hole would also disrupt the orbits of the planets, likely tearing the solar system apart. Next, let's look at a strange and theoretical possibility: replacing the Sun with a white hole. A white hole is the opposite of a black hole. While black holes pull in everything, even light, a white hole does the reverse. It expels matter and energy, and nothing can enter it. White holes are purely theoretical, meaning they haven't been observed in nature, but they follow the same equations as black holes. If a white hole took the Sun's place, the solar system would be in chaos. Instead of pulling planets in, the white hole would blast out energy, potentially pushing planets away. Earth could be hurled into deep space, or the powerful ejections of matter could destroy anything nearby. Unlike a black hole, which would suck the planets in, a white hole's energy blasts would destabilize everything around it. In any case, life on Earth wouldn't stand a chance. The intense bursts of energy would either strip the planet's surface or fling it far away, making survival impossible. Lastly, let's imagine replacing the Sun with a wormhole. A wormhole is a theoretical tunnel through space-time, connecting two distant points in the universe. Essentially, it's like a shortcut through space. Wormholes are fascinating in theory, but what if one took the place of the Sun? First, the gravitational effects of a wormhole would throw the entire solar system into chaos. Depending on the size and strength of the wormhole, the planets might be pulled into it or tossed out of their orbits. Earth could end up flung into deep space or sucked through the wormhole itself. If Earth did enter the wormhole, we could be transported to another part of the universe. An exciting but terrifying prospect. Another issue is the lack of energy. The Sun provides light and heat, But a wormhole wouldn't give off any of that. Without the sun's energy, Earth would freeze quickly, just like with Proxima Centauri or a black hole. There'd be no sunlight to support life, and temperatures would drop to deadly levels. Additionally, even if the wormhole didn't immediately destroy Earth, the gravitational forces surrounding it could cause extreme tidal forces, ripping apart planets and moons. Life, as we know it, wouldn't be able to survive the combination of freezing cold and gravitational chaos. In short, replacing the sun with a wormhole would lead to either the destruction of the solar system or Earth being sucked into the unknown, leaving life in the balance. Thanks for staying with us once again.